Hello friends, welcome to my channel Learn Computer Science and Application. Today in this lecture we will study first come first served CPU scheduling algorithm. FCFS scheduling algorithm is one of the simplest scheduling algorithm. This means जो फर्स्ट कम फर्स्ट सर्व शेड्यूलिंग एल्गोरिदम होता है वो इज द सिंपलेस्ट एंड द इजीएस्ट शेड्यूलिंग एल्गोरिदम होता है टू कोड. In first come first served scheduling algorithms, processes are allocated according to the arrival time, that is when the process arrive in the ready queue, according to first come first served basis, that is first in first out. First come first served scheduling algorithm is a non-preemptive scheduling algorithm, which means when a process has been sent to CPU for execution, it cannot be forcibly withdrawn from the CPU execution until the process runs to completion or it is terminated. In first come first served scheduling, long jobs make short jobs to wait, resulting in long waiting times. First come first served scheduling is also called first in first out, FIFO, run to completion, and last run until done. Advantages of first come first served scheduling algorithm. First come first served scheduling algorithm can easily predict time required to complete execution of processes by the CPU than most of the other CPU scheduling algorithm schemes. FCFS scheduling algorithm is the simplest and the easiest scheduling algorithm to write code and understand. Disadvantages of first come first served scheduling. One of the most important drawbacks of first come first served scheduling scheme is that average waiting time for processes to run by the CPU is very quite long, which results long jobs to make short jobs to wait, resulting in long average waiting times. Second, first come first served scheduling algorithms are not suitable for time sharing and interactive systems. In below example, I have explained an example for first come first served scheduling. In this example below, there are three processes in a system having their CPU burst time as P1 requires 24 milliseconds to get executed by the CPU, process P2 requires 3 milliseconds to get executed by the CPU, and lastly process P3 also requires 3 milliseconds to get executed by the CPU. Now the CPU burst time is the time needed by CPU to execute the process. When processes arrives in the ready queue in the order process P1 followed by P2 and P2 process followed by P3. I have described a Gantt chart for this schedule as follows. In this above Gantt chart, process P1 arrives at 0 milliseconds and get executed for 24 milliseconds by the CPU. Then process P2 arrives at 24 milliseconds and get executed by 3 milliseconds by the CPU. And lastly, process P3 arrives at 27 milliseconds and are executed by the CPU for 3 milliseconds. So as you see in the above Gantt chart, waiting time for P1 is 0 milliseconds, waiting time for process P2 is 24 milliseconds, and waiting time for process P3 is 27 milliseconds. Therefore, average waiting time for processes arriving in the order of process P1 followed by P2 followed by P3 is 0 plus 24 plus 27 divided by 3, which is equal to 17 milliseconds. Now suppose that processes arrives in the order process P2 followed by process P3 and process P3 followed by process P1. Now below I have designed a Gantt chart for this schedule. In this schedule, process P2 arrives at 0 milliseconds and get executed for 3 milliseconds. Process P3 arrives at 3 milliseconds and get executed for 3 milliseconds. And lastly, process P1 arrives at 6 milliseconds and get executed for 24 milliseconds. As you can see in the Gantt chart below, waiting time for process P1 is 6 milliseconds, average waiting time for process P2 is 0 milliseconds, and waiting time for process P3 is 3 milliseconds. Therefore, the average waiting time of the processes run by the CPU is 6 plus 0 plus 3 divided by 3, which is equal to 3 milliseconds. Thus we can see that average waiting time for the processes executed by the CPU depends upon the order of execution in which the process arrives. Students, in the next lecture, I will explain shortest job first scheduling algorithm in detail, that is SJF scheduling algorithm. स्टूडेंट्स, उम्मीद है आपको मेरा लेक्चर पसंद आया होगा. अगर पसंद आया है तो लाइक करें, शेयर करें, बेल आइकन को प्रेस करें और चैनल को सब्सक्राइब करना ना भूलें. थैंक्स फॉर वॉचिंग गाइस. थैंक यू.